Hello guys, so now we are going to do the design and analysis of the retaining wall, the cantilever retaining wall. So for that we have to open our software. So we can see the retaining walls near the bridges, the dams, everything. The retaining wall is for the retaining of the materials. So we will open our STAAD software. So after opening our STAAD software, go to new project. So then again we have to select the space and give the name. So I'm taking as a retain wall. So next, finish. So close this. So now we have to go to geometry and then go to run structure wizard. So after that, we have to select the frame model and select the grid frame. So here we have to edit to it's 1, the length is 1 and the height is 6 meters and the width will be 4 meters. So along the base it will length 1 and all these are 1. On apply. So here we can see our structure. So click on X and click on S. So here we can import our structure to here. Now click on OK. So structure will be into our drawing sheet. So now we have to, you can see here the 3D picture, the front, back, top, bottom. So after that, so now go to this front view and select these beams and click on delete. So because one side we're gonna have the sloped ones, so we're gonna take the slope. So okay. So after deleting the beams, so this is our project. So now we have to do the basings. For this we have to create the base. So for that we have to select this, and if we see translational repeat, now we have to go to, so our it will be 2 meters. So click on link step. So okay, so it has created. So again click on translational repeat. So we're gonna take as minus 1.2. Click on link steps. Okay. See, our retaining wall has selected. Again select this. Go to translational repeat and then click on Y direction. So the spacing will be, so after that we will place this, and so now we have to take in Y direction and it's minus 1.2 and click on link steps and OK. So see here our base has been created. So now we have to select the 4 node plate and give plates to this. So now I'll add the nodal plates to all these members. So we will add all this, and here also. So after adding all the nodal plates, we will delete the beams. So look on delete. Yes. So the beams have been deleted. So now we will go to general. So for our support conditions and our properties, so we will give the property. So we are taking, so go to thickness, and now we will assign this thickness as, for the base one we will take it 0.4. So click on add, and another thickness we will take as 0.2 for everything, and we will add, but here we will change for the some thickness, like it's 0.15 and it will be 1.1. We can add and close. So for the first plate, we have to take assign user cursor to assign. So assign here and here. Select this user assign this one and this one and this one. So after that, select this further assign to assign. Select this user to assign and assign here. So we can see in 3D. So we have selected this one. So deselect and see our returning wall has evolved. So after that, we will go to support and we will create. We'll take the fixed one, add. Now select the support and we will go to the front view and select all these node points. So after selecting the nodes, click on assign and select nodes, assign. So here we can see our node points have been assigned. But here we missed it. So select these two nodes and assign. So it will be assigned. So after we will do the loadings. So go to load cases. Click on add. So we will add some load cases overall here. So go to the dead load and give the dead load. Click on add. So after that, we will go to the live load. So name it as LL. So click on add and close. So go to dead load, click on add. Now add the self rate and close. So go to live load, click on add. So go to plate load and click on plate on full pressure. So we're gonna take this as a full plate pressure. So we'll be taking -15 and it's in the Z direction. Now it's ZY. So now click on add. And so now we'll assign the self rate, assign to view, assign S. So now we'll assign this. Now select this structure and select this plate. Assign the selected plate, assign S. So see. For this, we're going to take as the GX change place. So then, after that, we're going to select this one, which is in the GY for this plate, and we'll select the assign plates, and this one assign S. So see, it has been assigned. So now we'll select the materials from concrete, assign S. So now we will do analysis, add, close, and so now we will go to analysis, click on run analysis. So see, our result has been analyzed. Now go to post processing mode, select all this, click on OK. So see, here we can see the reflection and the reaction of this due to the load. So we'll see the animation, click on deflection, click on OK. So see here, the load, the wing is deflecting, the retaining wall is deflecting. So due to live load, this is due to dead load, and that's all. This is due to live load. So now we'll create the plate with the maximum absolute. Okay. So this is the maximum absolute pressures for it. So we can see the reactions also, nodes, reaction, all the how much reaction is taking place. So everything we can see here. So for stresses, go to animation, plate stress contour, maximum absolute, go to animation, click on stress. Okay. So this is the stress distribution for the retaining wall due to earth pressures. And you see here, so this is our design. So if you want to take the reports, so we can click on this. So it will give us the reports of our everything about STAAD code results. So now we will go to design, click on design, click on concrete. Now go to IS code, select the parameters, deselect all these, select this compressive, yield strength. Okay, we go to define and take it as 25, add and F5, 500, and close, commands, take off, add, and close. So now go to this one and click on assign to view, assign as FY, assign to view, assign and S. So now we will go to analysis, add and close. So now we have to click the analysis, click on run analysis. So we have done with 0 warnings and 0 errors. Click on done. So now we can see the design. So we can see the plate, select on the plates, the image absolute. Okay. So this is how when you press on these plates, so it will show all the properties. We can dead load, live load, corner stresses, geometry. So we can see that each plate, what are the stresses acting and how the plate's properties, constant stresses are happening due to the live loads and everything. So if you want to take the results along the line, we can take it and the contours. So we select this, okay, the spheres and the nodes. If you click the reports, you can see the output and click on this. Okay, so everything will be defined for us for the nodal displacement. So the place center stresses for all the plate sets and summary. So after that, so you can see our model. So this is our retaining wall model for the construction 4 meters. So you can take your own structure for that and we can draw this. So in modeling also, if you go to these reports, so we can see the concrete design for these materials and how much loads and the supports, the thickness. You can see the density, alpha and everything in the reported file. If you want to print, click on this print, Microsoft print. Okay. So it's going to printing a file and it will ask for the saving of location. So give some name and click on save. So it will save all the pages of our documents related to or support. So all has been saved. So this is how we can do retaining wall analysis and design in STAAD.